Hello math lovers, welcome to the channel. We are going to prove a formula in this video, so let's move on. The formula to find the number of the diagonals of a convex polygon is n times n minus 3 over 2, where n is the number of sides of the polygon. So we have to prove this formula. So let's prove it. You have to think of any convex polygon having n number of sides. So a convex polygon having n number of sides will also have n number of vertices, because the number of sides and vertices in any given polygon is the same. So we are to find out the number of diagonals in it. So among n number of vertices in this polygon, if we take a pair of vertices, then there are several such pairs in a polygon. Among these pairs of vertices, some of them are diagonals and some of them are sides of the polygon. A diagonal is a line segment that joins two non-adjacent vertices, whereas sides are the line segments that join two adjacent vertices. So we first find the number of combinations of two vertices of this polygon. So this combination is given by nc2, that is the combination of n vertices taken two vertices at a time. So we have nc2 equals to n factorial over n minus 2 factorial times 2 factorial. We can write n factorial as n times n minus 1 times n minus 2 factorial, and the denominator we can write as it is. So now we can cancel out this n minus 2 factorial and n minus 2 factorial in both the numerator and the denominator. So we are left with n times n minus 1 over 2, because 2 factorial can be kept as 2, because 2 factorial is 2 into 1. So that will be equivalent to 2. So now, as I have told you earlier, that these combinations also include the side of the polygon as well as the diagonals of the polygon. So we have to remove the sides of the polygon from this formula. So how can we remove the sides of the polygon? So we can deduct n from this formula, because n is the number of sides. So here n times n minus 1 over 2 minus n will give us the number of diagonals. So now this can be written as n times n minus 1 minus 2n over 2 by taking 2 as LCM. Now we can take n common from both these expressions. So if we take n common, we are left with n minus 1 minus 2 over 2. Now n minus 1 minus 2 will become n minus 3. So finally we have our formula, that is n times n minus 3 over 2, hence it is proved as required by the question. So friends, now let's do an experiment with what we have learned. We have to get a convex polygon. So I have chosen pentagon because it is my favorite polygon. What's yours? You can comment me if you want. So as we know that a pentagon has 5 sides and 5 vertices, that is n equals to 5. So if we take pairs of vertices from among the total number of vertices, and then the total number of combinations will be given by nc2. So in our case it is 5c2. 5c2 is 5 factorial over 3 factorial into 2 factorial. So that will give us 10 combinations of the pairs of vertices. So these 10 combinations of the pairs of vertices are AB, AC, AD, AE, BC, BD, BE, CD, CE and DE. So among these 10 pairs of vertices, we have some of them as sides and some of them as diagonals. So we know it that there are 5 sides. So what are these 5 sides? So these 5 sides are AB, AE, then there is BC, CD, and then there is DE. So we have 5 sides that is reflected in these 10 combinations. So if we deduct these 5 sides from these 10 combinations, then we are left with 5 diagonals. So these 5 diagonals are AC, AD, BD, BE and CE. Formula wise, if we replace n with 5, then we get 5 times 5 minus 3 over 2. So 5 minus 3 is 2. So 2 cancel and we are left with 5 diagonals. So we see that what this formula has given, that is 5 diagonals, is true to our observation. Hence this formula to find the number of diagonals of a convex polygon is true. Friends, before I conclude, let's go with one more convex polygon. So this time it will be a triangle. So friends, what do you think, how many diagonals this triangle have? So keep the answer in your head. We'll check it using this formula. So if we keep 3 in place of n, because a triangle has 3 sides and 3 vertices, so n is the number of sides, so let's keep 3 here. So if we keep 3 here, then we get 3 minus 3 equals to 0, and when numerator is 0, then we'll have a 0 in our answer. So this formula gives us 0 diagonals for a triangle. If we observe, then we see that this is true because a triangle is the only convex polygon with no diagonal. The vertices of a triangle join to form its sides. There are no diagonals in a triangle. Thank you friends, maths is fun.